Two impossible black holes collided. New Glenn sends Escapade to Mars and lands its booster. The dangers of micrometeor storms on the moon. And in Space Bites Plus, the weird weather on Venus. All this and more in this week's Space Bites. Well, hello everyone. I'm on the road for the next month, so there's going to be a lot of these videos where I'm filming in various Airbnbs and hotels. I'm in Thailand, and my wife and I have always wanted to be here, and this is a chance to escape the cold Canadian winter for at least a month anyway. I'll keep you posted and try to give you some B-roll of us doing various Thailand things as we go through the next month. All right, let's get into this week's stories. So it's only been a few years since we've been able to actually detect gravitational waves from colliding black holes, colliding neutron stars, and astronomers have learned a tremendous amount about these collisions and the release of gravitational waves. In 2023, astronomers detected a very bizarre gravitational wave event where two black holes that shouldn't exist were able to collide and create a more massive black hole. Now, according to the theory of how black holes form, when you have a massive star, it reaches the end of its life and then it implodes. If you have more than about 20 times the mass of the sun, you will get a black hole. And, not a very massive black hole, but then they get more and more massive over time. And that the limit to this is about 70 times the mass of the sun. Beyond 70 times the mass of the sun, the forces that are going on inside the heart of the star is something called a pair instability supernova. And, it's a whole other topic, but the gist is these things just blow themselves apart. They don't leave a black hole as a remnant. And you get these pair instability supernovae from about 70 times the mass of the sun up to about 130 times the mass of the sun. And then beyond 130 times the mass of the sun, if such stars even do go supernova, then you will get a black hole, but it's that in-between size. And so when astronomers see a black hole that is in that in-between region, they have to wonder how it happened. Now, it's not impossible, obviously, that you could have black holes that merged a couple of times before they got to that intermediate mass black hole. But when you've got a situation with some kind of a binary pair of stars, it'd be very weird to have another one join the mix, that you would have had two massive stars in orbit around each other. One went off as a supernova, turned into a black hole. The other went off supernova, turned into a black hole. Then they found their way together, and then they collided, and they made a more massive black hole. And so in this event in 2023, you had two black holes, one with 137 times the mass of the sun and one with 103 times the mass of the sun. And so these are sort of in that forbidden zone. So how did this happen? Well, astronomers have been thinking about the effect the magnetic field of the star has on its mass. And that if you start out with a star that is very massive, like they simulated up to like 250 times the mass of the sun, as it's rotating, if there's a lot of magnetic fields in its environment, then it will shed a lot of material and get itself down to a smaller size. And so even though it started out as a much more massive star and should have detonated as a pair instability supernova, it can shed enough mass that it has a core that allows it to just still become a regular supernova with a black hole remnant. So I think this is the way that they were able to get to these black holes in the forbidden zone. We've got a story about this by Mark Thompson on Universe Today. We had a scrub last week, but just a couple of days ago, Blue Origin's New Glenn rocket took off for the second time. And this time it was carrying an actual payload, two satellites for NASA called Escapade, as well as another mission on board. And there had been a lot of delays, I guess, as New Glenn was in the final stages of development. We saw a test launch, but they didn't actually land the booster rocket on the first time around. And now this time they did it. They launched the mission, they recovered the booster, it landed several hundred kilometers offshore on the recovery vessel called Jacqueline. And so New Glenn is now an operational rocket, which are like words I thought I would never say. And yet here we are. It's a very strange time. But New Glenn is able to carry 50 tons to orbit, which is actually a little less than the Falcon Heavy. And obviously it's going to be way less than what theoretically Starship is going to be able to do. But it has this reusable first stage and then a disposable upper stage. So it's a little less than the capacity of the Falcon Heavy rocket, but it's about twice as capable of carrying payloads into orbit than ULA's Vulcan rocket. And Blue Origin is hoping that they're going to be able to use each booster about 25 times. And so now Escapade is off to Mars to try and figure out where Mars's atmosphere went. More than a decade ago, NASA's Fermi telescope detected an excess of gamma radiation coming from the center of the Milky Way. And this has been a compelling mystery for decades now. And so one source of this excess gamma radiation could be annihilation of dark matter at the center of the Milky Way. So, we still don't know what dark matter is, but one theory is that if dark matter is some kind of particle, when those particles are in a very dense environment around the environment of the black hole at the center of the Milky Way, then they will find their way to each other and they will collide and annihilate. And when they do, you will get this release of gamma radiation. But there's another idea, and that is that actually you're seeing all of this gamma radiation coming from pulsars that are around the center of the Milky Way, and a very special kind of pulsar called a millisecond pulsar. So pulsars are just a type of neutron star. When a massive star dies, collapses in on itself, you get a neutron star. Like when you're above 8 times the mass of the sun, you get a neutron star. And when a neutron star first forms, it's rotating very rapidly, and this is where you get pulsars. And if the environment around the pulsar is sort of special, people are still figuring this out, then you can get a pulsar that is spinning almost 1,000 times a second. And it generates these really powerful magnetic fields around it. And these magnetic fields interact with the particles around the pulsar. And this could be the source of the gamma radiation. So astronomers looked at the data and they calculated the shape. They mapped out where all of this excess gamma radiation was coming. And so the theory for the dark matter annihilation as the source of the radiation is that you would see this sort of spherical halo around the center of the Milky Way. But with the pulsar idea, you would see something that's more box-like shaped. And based on the observations, it more matched that boxy shape. And so it looks like the excess gamma radiation is coming from millisecond pulsars around the center of the Milky Way. We've got a story about this from Andy Thomaswick on Universe Today. About 100 tons of rock and metal is hitting the Earth every single day. And this is just like leftover material from the formation of the solar system. And this rock and dust burns up in the atmosphere, and so it doesn't trouble us. You go outside, you see a nice meteor shower, but that's it. But on the moon, there is no atmosphere. And so all of these particles make their way all the way down to the surface. And they can be going 70 kilometers per second. And now many of the particles can be very small, like a millionth of a gram, but others can be as large as 10 grams. And there's this constant weathering that's happening on the surface of the moon. So scientists wanted to understand how much of this micrometeorite damage is happening on the surface of the moon. What would the implications if you built a lunar base on the moon? What they found is that there are between 15,000 and 23,000 micrometeorite impacts over the course of a year in an area that's roughly equivalent to, say, the International Space Station. So like they wanted to simulate what would happen with a lunar station that was kind of the same size as the International Space Station. And they found that that area would receive between 15,000 and 23,000 of those micrometeorite impacts every year. Now, it's not constant, so there are places where there are less impacts, like at the poles of the moon, and places where there are more impacts, like in the sort of middle regions of the moon and the side that's facing the Earth. This isn't a total disaster. You could put what's called a Whipple shield onto the exterior of your base. And so that will sort of ablate as these micrometeors are coming down. And eventually you have to sort of put new shielding on top of your space station. But for astronauts, they're going to be walking around and there's kind of like nothing they can do to protect themselves. Like most of the time, it won't be a problem. But every now and then a particle will hit, or there'll be shrapnel from a hit that goes nearby and could cause damage. So this is one of those risks that people are going to have to face when they go to the moon. We've got a lot more information from Mark Thompson. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was that Comet 3I Atlas is turning bluer and has been getting brighter. So thank you everybody who voted last week. Now we're going to put this week's vote into the post tab on the channel. So the best chance is to subscribe to our channel, click on the notifications bell, and then you have a better chance of the algorithm showing you new ones into the future. Astronomers are starting to suspect that there are a lot of rogue planets out there. A recent estimate is that there are probably 2 Jupiter mass rogue planets for every star in the Milky Way. So there are like 200 billion Jupiter-sized rogue planets, and many of these are going to have moons. Now, the planets themselves, they don't sound very habitable. There is no star, so it's going to be very cold on the planets. But for the moons orbiting around it, you've got these tidal interactions, similar to what we have with Jupiter here in the solar system. If you get a Jupiter rogue planet by itself, and maybe it has moons, the moons are going to be in a fairly stable circular orbit. And so they're probably not going to have a lot of this tidal interaction that warms up the moons like what we have with Jupiter. But astronomers think that if this exo-Jupiter, rogue Jupiter, is part of a star system where the star goes supernova, then that can kick out the planet. And they calculated that the moons can come along for the ride, but their orbits will get all mixed up and they'll become highly eccentric. And with these eccentric elliptical orbits, then you are going to get all of those tidal interactions. It can be quite extreme. And so that could sort of melt ice on the surface of these moons. It could release a lot of energy, and then that could be a source for life. And so while the planets probably aren't habitable, there could be life on the moons around rogue planets. We've got a story about this from Evan Goff. Euclid's mission is now in operation. We've been getting a lot of really interesting science from this spacecraft. Now, it flew out to the Earth-Sun L2 Lagrange point, the same place where James Webb is, and it is now collecting survey information about the large-scale structure of the universe. And we've got some cool pictures that we're going to show you in a little bit, but first let's talk about Euclid. So because it's at the L2 Lagrange point, this is an unstable Lagrange point, which means that you have to use propellant to be able to remain in this region. Once you run out of propellant, you start to drift away from this. And this is how the Gaia mission ended, is that they ran out of propellant and they had to shut the mission down. This is how James Webb will end. And this is how the Euclid mission will end. But how long you get to do your mission depends on how good the launch was. And so the European Space Agency just calculated that Euclid got probably an extra 8 years of mission time thanks to how accurate its launch was when it was deployed into the Lagrange point. So 8 extra years of science. I've got a story about this from Andy Thomaswick. And so speaking of Euclid, here is a new picture. Now, Euclid's main job is that it is doing this large-scale survey of the universe. It's looking at how the distributions of dark matter are over time as it looks back into the early universe. Got 2 instruments on board. Visible light telescope that allows it to look at the light coming from galaxies and measure the shape of the galaxies. And it has an infrared instrument on board so it could do spectroscopy to measure the distance of these galaxies. And so with this infrared camera, it's able to do observations of the same kinds of things that James Webb can do. In other words, look at nebulae that appear dark in optical instruments and see through all of the dust and gas that is blocking our view. And so here's a cool picture of the Orion molecular cloud, which is a relatively close star-forming region to us. And there are about 1,000 newly forming stars. When you look in visible light, the whole region is very dark because it has a lot of this cold molecular gas. And then inside, you've got new stars forming. But in infrared, it can go through the gas and dust and to be able to see where these new stars are forming. And so cool picture from Euclid. And even though there are about 1,000 stars in this nebula, they're all small stars. So it doesn't have any of the large O and B stars that you see in other big star-forming regions. I've got a story about this from Evan Goff. And this is a feature on Mars called a recurring slope lineae. And this has been an unfolding mystery on Mars, where astronomers have been seeing these slope lineae. And I don't know if you remember that we got this really big announcement that people thought there's probably liquid pouring out of the sides of craters on Mars, because you see these dark streaks down the sides of craters. And so planetary scientists thought, oh, when the seasons change, conditions warm up, and maybe you've got like trapped carbon dioxide or maybe even water that is pouring out of the side of the crater and going down the side of the crater. But another theory has been growing, and that this is actually has nothing to do with liquid, that this is actually impacts where you're getting landslides. And so you're getting fresh material that is being revealed, and it's much darker than the other material that's been weathering over thousands of years. And so in this picture, you're looking at a dust avalanche in the Apollinaris Mons region. In the bottom where this avalanche is happening, there's like evidence of meteorite impact on Mars. And this is giving more evidence, the idea that these streaks are really caused by impacts from nearby meteorites. I've got a story about this from Matt Williams. Now, you're watching this episode of Space Bites on YouTube, and the problem with YouTube is that they really love advertising. They force us to put ads at the beginning of every video. They encourage us to put many ads in the middle of this video and even at the end of this video. We don't, because we have an option, but we can't get rid of the ones at the beginning. So we recommend that you watch these episodes over on Patreon, where we release them completely ad-free. And you don't, this isn't some way to trick you into signing up. It's completely free. You don't have to be logged in to Patreon to watch this video, but you get to watch it without any ads. And to show you that this is better, we put one additional story into that episode to really encourage you to go and watch it over there. So I'll put a link in the show notes, and this week's bonus story is about how scientists are starting to understand the weather on Venus. But if you want even more space news stories, we're reporting tons and tons on Universe Today. Dozens of space stories that you're not going to see here or really anywhere else on the internet. For example, here is a suit that you can wear that simulates Earth's gravity to stop muscle loss when you're in space. Google has a plan for a space-based computing. And do interstellar objects pose a threat to Earth? Now, I write a newsletter every week that gathers together all of the stories that we cover on Universe Today. So you've got it all in one handy place. I write every word in the newsletter. It's completely free. So just go to universetoday.com/newsletter to sign up. So I'm going to talk about the end of the government shutdown. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Balog, Cy Nielsen, Dark Finga, Dave Veryroff, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Nord Space, OneStepForAnimals.org, Paul Roebuck, Brent Kaidu, Richard Williams, Sean Sargent, Stephen Fowler-Munley, Team 49, Telescopes Canada, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So for the last 40 days, I had been watching what was going on with the US to understand when the government shutdown was going to end so that we could get NASA information back. And today, when I was going through my process of looking through all of the space news stories, I noticed all the NASA feeds were back. There was new stories across all of NASA. And this was exciting because my space news feeds have felt very empty without NASA's contribution. And now they're back. And we got a bunch of, stuff from the space station and stuff from the Escapade launch and a lot of other stories. But the one that we're all waiting for is, did the Mars Reconnaissance Orbiter take pictures of Comet 3I Atlas when it went by? Now, I haven't seen these pictures yet, but it's still early days. And so hopefully, maybe by next week, I don't know, we're going to be able to find out more of this. So, this is good. This is a relief to me. I think I mentioned a couple of weeks ago that, it was actually really hard to do reporting without having all that NASA information. So, for everybody at NASA, I know you're going through a tough time right now, but thanks for being able to get more information back out to all of us. All right. I will see you next week.